Okay. All right, so first thing we talked about was accuracy. Circle that. And around accuracy, there are two things we needed to determine something to be accurate, and that was the unit. The unit that is used, it has to be standard. So inches, meters, centimeters, millimeters, Celsius, Fahrenheit, anything that you recognize, of course, and scale has to be appropriate. This is going to be pretty much filled in. So that's why I'm using the space like scarcely, I guess. So we need that for something to be accurate. The definition is how close you are to the target. How close you are to the target. You should be able to repeat it. Measurement. And can be affected by two things. Anybody remember two things that could affect your accuracy? First one was damaged. If the device you're using, whatever, it's a cup, a ruler, whatever, if it's damaged. Damaged device, I'm just going to say that. And the other one is improper use. So if somebody's not using it properly, like if you're using tablespoons or teaspoons to measure off ingredients and you're not skimming off the top, right? That wouldn't be appropriate. If you're grabbing a cup of water and then flour, there's some flour left behind. So technically, you haven't been using it properly. If you leave a cup outside in the sun or in the elements, right? It could be cracked and some of it could be leaking. So some of them are silly, but nonetheless, they get to the point where if it's damaged, it's not going to be accurate. Then we talked about precision. But both precision and uncertainty relate to accuracy. Okay? But I'm kind of going to cut it off right here. Talked about precision. And the definition would be limitation of measuring device. So I will say this next to it, the increments. And never say that, oh, this device is more precise than the other ones because it has more markings on it. That's not what it's like. How much does a marking represent, right? could be 0.2 centimeters and the other one 0.1 centimeters. So you got to figure out what am I going up by precisely, right? So there's three ways to get precision. To read precision, you could have a picture, words, and it says markings, or a number. And I'll just go 3.723 grams, let's say, right? Then based on this number, we are assuming that that's going to give us our precision. And you fill out the rest with zeros, right? So my precision there is 0.001. No surprises there. But I will circle this whole thing. This is kind of like a subcategory. Okay? And make an arrow from precision to it. I would say smaller increments. Can we turn down the music there? Somebody's blasting. I can hear it up to here. Smaller increments is equal to greater precision. Okay. So that's also connected to precision. And I'm going to kind of section that off to talk about our next topic, which is uncertainty. The definition of that is margin of error. And it's caused by limitation of device. So remember, uncertainty is always there, even if you say, like, how long did it take you to get to work? Oh, 10 minutes. Well, is it really exactly 10 minutes, right? There's always a certain level of uncertainty. We're all round, and that's okay. But in certain industries, it's not okay. Right? We all know that uncertainty is just precision divided by 2. No news there. We've done it over and over again. But then there's the, remember that there's the measurement plus or minus the uncertainty. right? That's also connected to that. But further to this, there's the combined measurement plus or minus combined uncertainty. Combined measurement plus or minus combined uncertainty. That is when you're adding stuff, putting stuff side by side, or you're adding ingredients. And I will say, I'll put a little star next to combined. Okay. Always add uncertainties. No matter what, even if you're taking away or like using a little jug to take away water, to draw water from a big pail, right? Yes, you're subtracting the amount, but you're always adding your uncertainties. And I would say this flows, right? This flows from that to this. So every measurement has its uncertainty, so you should be able to figure it out individually for each item or volume, right? And then later on you would add them all up. That's it for uncertainty. A greater precision is equal to a smaller uncertainty. Should I add that? I think I will leave it for now because I'm going to run out of space because this is my last section here, which is tolerance. And the definition of it is the range of acceptable measurements. And this is caused by, if you watched Friday's lesson, I gave folks the difference between uncertainty and tolerance. And I asked them to write it down on page 94. I won't spend a whole lot of time on it, but uncertainty is caused by the limitation of the measuring device. Tolerance is due to, there could be some human error, equipment malfunction, precision limits. So the tolerance is set by the industry. The uncertainty is set by the device you're using, right? So uncertainty is caused by whatever you're using to measure. Tolerance is in part due to this, but it also has other components that it's taking into account. So that is the main difference. So I'll say caused by human error, equipment, precision, and uncertainty, and the list goes on. It's set by the industry. The industry that you're working in will set the tolerance. What is acceptable, what is not. Okay, it's not just random, it is decided there. Okay, and here's my test checklist. Here it is. There are four ways to write it, to state. Okay, so there's the max and the min, like this. That's one way. There's the nominal, plus or minus half of the tolerance. That's another way. And these ones are very similar. So there's the max and the min, right? The max would be plus 0 here, the min would be minus 0, right? So it'd be minus tolerance plus tolerance. I would say always come up with max, min, tolerance, nominal. Like have that checklist and then you can branch off into any one of those. Tolerance is the max minus min. Okay. I'm going to do the state 4 ways. I'm going to circle all of that. This is just the range, right? Nominal is the target. Here I am gonna just tell you, once we're done the ACs, I'm gonna tell you, you can start, and I made the key to some of it. Page 12 to the end of booklet. This is the workbook, right? That's the workbook. And it starts with this. I'm just going to show you once on the screen. It says tolerance worksheet. That's a very good one because it's starting at on question 3. It's asking you to write it in 4 different formats based on the information you're given, right? So you learn how to come up with the 4 things that you should always be able to draw from the information and then state it in 4 ways. Okay. All right. I hope this helps. We're going to pause it here. Okay. Don't inflate anything. Just, it is what it is. That's what we're after. Okay. Describe the difference between uncertainty and tolerance. And obviously, it's only worth 1 mark, so you don't need to go to a great extent here. But this is due to measuring device. Due to limitations, right? So in the precision of the device, right, kind of sets the uncertainty. Tolerance is set by the industry. And it's due to many factors. One of which could be human error, precision, equipment, and so forth. Okay, so this is set by the device, the other one is set by the industry, and it does encompass some of the uncertainty and precision issues, but it's not only because of that. Some students think they're the same thing. They're not the same. Okay. Define tolerance using your own words, right? Range of acceptable values. Okay. Give an example. If I do ask you for it, right? You can use medication as probably the best, the one most of us, or electricity, or fitting a window or a door, right? For a window, small enough to fit, right? Large enough to close gap, right? You want a tight fit or something like that. prescription drugs, right? High enough of a dose to actually have the intended effect, but not too high, right? Low enough to not have any side effects or serious side effects. In each case, I'm just going to do it. Nominal should be a home run. Okay, just grab that front number. The max here, you add. You would go this plus that to get your max, 0.0186 of a meter. And the min is just the same as the nominal because you're not subtracting anything, right? So that's that. 1 mark for this, correct. And then this one here, I actually wanted to put the tolerance in. So if I do ask you to put on a test, there's a very high chance that I'm asking you for the tolerance on top of these three. So just go max, take away min. That's how you get your tolerance. In this case, it's going to be, right? In this case, it's going to be that up there. But to be safe, right, just go max minus min, like these two. Once you've determined that, subtract them, you get your tolerance there. Here, the max is 0.048 of an inch, and the min is 0. Let's see here, 0.18. Yeah, okay. Yeah. And then again, tolerance. What would be your tolerance here? You subtract these two. Okay. So 0.048 minus 0.018. And is that 0.03? Yeah. That would be a tolerance. I didn't ask you to do it, so don't worry about it. But if you subtract those, then you get that. Some of you will see it right here, right? The tolerance is the difference. Next, given that the tolerance of a pipe is this, state the tolerance in the three other forms. I will stress this. Listen carefully. This is not the tolerance. Why not? Because there's not a half in front of it. You know how your study sheet will have it stated like that? You will have this on your study sheet, right? Oh yeah, so whatever's in there, that's your tolerance. Only if there's a half in front of it. Only then, okay? So let me erase that so you can see. So three other forms. What I will do here is max, min, nominal, and tolerance. I'll do that on the side here. The max is 355.75. The min is 355.25, right? I just subtract this. The nominal is 355.50. And the tolerance, I'm going to subtract these, but I know it's 0.50 centimeters. Everything is in centimeters. Oh, you can't see that, sorry. There. Yeah, go ahead. So I have this here. And now I'm going to write it. So max min is already there. So I'm just going to go 355.75, 355.25. So done. This one, I'm supposed to grab the max. So bear with me. I know some of you already, you know that you got it right, but that's okay. Focus on the little things like the units, right? The other one asks for the min, minus 0 plus whatever the tolerance is, which is 0.50 centimeters. So 3 marks there if you got that right. Okay. I will probably on a test make you do this. I will actually give you marks for it, and then when you branch off, then I'm going to base it on this. So if you lose a mark here, you still get some marks for writing it correctly thereafter. Jenny's sewing together 2 pieces of fabric. And why don't we do that? Both of them have the same precision, correct? Correct? So precision is 0.1, uncertainty is 0.05. This is what I'm going to focus on. So 46.5 plus or minus 0.05. That's for the first piece. The second piece has the same uncertainty, so you can just add. I don't have the key in front of me, so I will 114.4 centimeters plus or minus. You add that up, you get that. You would get 1 mark for this part right here. Just getting this right, you get 1 mark, and then you get your max and your min from that. The maximum possible and the minimum possible. So you just add that, so that's 114.5 centimeters, and this is 114.3 centimeters. You get 1 mark for each of those. So this is where some students are, oh yeah, that's the max and the min, that's tolerance. No. This is just due to the uncertainty. Whenever we install these or sew them together, we could have a piece that is this long or a piece that is this long. That's what uncertainty, when you talk in precision uncertainty, that's what it is. Okay, so I'm not going to mix that up, and I'm going to ask you like the difference maybe, like on a question, but I'm not going to mix it up in a question like this. Okay, let's keep going. So this page is worth 3, 6, and another, that's 9, 10, 11. So this page is worth 11 marks. And the back side. Explain which beaker is more precise. Be specific. Don't just do this one. Don't say that one. You're not going to get marks for it. Okay. You have to show some worth. And so I will do this. The precision for this one, right? You can tell you're going up by 10, right? So it's 10 milliliters. The precision for this one, just go by the markings. From this marking to the other marking, it's clearly 50, right? So beaker A is more precise since it has smaller increments. It's okay if you tell me it's going up by less, it's going up by a smaller amount. I'm okay with that. Use your own words as long as you're conveying the message. So 1 mark for showing the work here and 1 mark for having a statement telling me which one and why. Okay. I should just say this, I might be a little sneaky on this one, that it's not a nice round number. It might be 25.5 or something that it's going up by, so be careful. Because we've done a lot of these that are just like straightforward, I want you to think and just make sure you get it. It's possible to figure out. You just have to take your time, okay? Take an extra second, maybe. It's not that much harder. I'm not trying to scare you here. Given the tolerance in this format, state the nominal. This should have been a home run. I hope so. It's the big number up front. That's all I'm trying to. So it could have had a +7 up here, right? It doesn't matter. The first number is always the nominal. It's what we're aiming for. And if we're off on either end, that's fine. So here, you have a 2x4. It's just a piece of wood, like a piece of, we call it 2x4, right? But this is recorded this, but the target is actually this. So we're focusing on these 2 measurements. This is my target, but I'm obviously off. So why is that? Okay, accuracy problem. There's an accuracy problem here because you're not hitting the target. Okay, and why is that? It could be Trevor's measuring tape may be damaged.
All grade 11s who are being immunized are to head to the cafeteria now. That's all grade 11s who are being immunized are to head to the cafeteria
It might be that Trevor might have not been careful enough. So here's the example. Let's say that this is an extreme example. Let's say that piece of wood is warped, right? And Trevor just measures from here across to here, right? But that, like, this happens all the time. It's bad. If I've worked in construction a little bit, if you leave that 2x4 sitting for a week, it's gonna be all warped. So it might have been that he didn't like make sure it lays it out flat along the piece of lumber to make sure it's 2.43, right? So careful enough to account for bends in the wood. So that's improper usage. Or it might have been that the piece of lumber was warped and he didn't lay it out flat or something like that. So you're saying either it's damaged or it's faulty usage, right? You didn't use it properly. I would say if it's damaged, I know that I had measuring tapes where the markings were off, like they were like scratched off over time because you're using it so much, right? So maybe something like that, or that little lip. You know, that little lip on the measuring tape gets loose after a while. So you have to kind of account for that. Anyways, many different things that could go wrong. Okay, how about this? I think I'm going to let you keep this one. I think it has enough stuff in there that will help you. And I'm going to give you the rest of today's class, so about 20 minutes to just update your study sheets, maybe look at your notes. If you want to start working on page 12 in the workbook, I'm going to post the answer key to that tolerance worksheet. You can do that. It's up to you. There's the uncertainty worksheet. Just make good use of your time, okay? That's all I'm asking.